everybody. Now we're going to talk about regression and look at problem 3 and our very few more problems. And as you can see, I have part of the output shown in front of you, and we want to go through a couple of the questions. So the first one is to find the least squares regression equation, and that's actually very simple. If you go to where it has intercept and then x and run down the coefficients, the intercept is your y-intercept, and I just put it at 0.5492 on ours. Then the slope component is the 1.4798. So in order to answer this question, let me scoot the page down. What is the least squares regression equation? The 0.5492 plus 1.4798 times x. Remember, this is an equation of a line, so it's going to have an intercept and a slope component. Okay? Now, we want to test for beta 1, and the reason that we do this is to test for informational capacity, and we want to see if beta 1 is equal to 0 versus beta 1 not equal to 0. And just for the record, if you fail to reject, your model doesn't provide information, your best bet for forecasting would just be the y-bar, the sample mean. So we really do want to reject HO. So what we're going to use is something called the p-value. And let's scoot back up to the printout, and let me scoot it over. See if it'll let me scoot over. Oops. Okay, it's not letting me scoot over. If you look on your, wait, let me look one more place. See if it'll let me get to one more thing. I know, let's try this. Nope, still not over there. If you go back and look where it says significance of f, I don't know if you can see that on here or not, but it's 0.00867. That's your p-value. That's what you want to use for your testing processes. And let's go back down to the next page. So that's p-value, the 0.00867. So our rule is, and we learned this when we were talking about z-star p-values, if p is less than alpha, then we reject HO. And typically the alpha level you use in regression is 0.05. So we would indeed reject HO. This is a good model. It provides information. Finally, if the amount of plastic is 0.5 pounds, what size of household do we expect? Now, notice this is an expect. It's an expected value, so it doesn't necessarily have to be an integer, so don't get worried about that. All you're going to do is take your least squares regression equation and then plug the value into where your x is. So you're going to have your 0.5492 plus 1.4798 times 0.5. So you'll have your 0.5492 plus 0.7399, and that gives me 1.2891. Okay? That takes care of the regression. Thanks. Doesn't want to let me leave. There goes the clock.